The learning objectives for today's lesson is to be able to evaluate logarithmic expressions and graph logarithmic functions. So what is a logarithmic function? Well, let's firstly consider this function here. F of x equals 2 to the power of x. So we have x, which is a variable, as an exponent. So this is an exponential function. Now, if we want to draw the graph of this function, we would produce a table of values like this. And when we graph this, it would look something like this. So we can see here, we have a y-intercept at 0, 1. Now, generally speaking, if we want to graph the inverse of this function, we would interchange the y and the x values. Okay, so over here we have y equals 2 to the power of x. Its inverse would be x equals 2 to the power of y. And these values that we have here are simply interchanged values over here. So you can see the x equals minus 3 over here becomes y equals minus 3. The y equals 1 over 8 over here becomes x equals 1 over 8 over here. Now, if we graph this, you can see this is what the graph looks like. Okay, and we can see there's an x-intercept at 1, 0. And you can see that the y-axis is an asymptote for this inverse function. Okay, and just lastly, we can see it's been reflected in the line y equals x. Now, if we have x equals b to the power of y, b is known as your base, and y, which is the exponent here, is known as the logarithm of x. Now, the logarithm of x, this is generally how we would write it. So y equals log base b of x. Please make sure you make a note of how to pronounce what we have over here. Now, y equals log base b of x if and only if x equals b to the power of y. And there's conditions on b and x. And they are such that b has to be strictly greater than 0, so it has to be positive, and b cannot equal 1. And x has to be strictly greater than 0, so you can see here x has to be positive. And you can see on the graph here, okay, x being less than or equal to 0, the logarithmic function is undefined. So please be sure to make a note of this as well. Now in example 1, we have two equations which are in logarithmic form, and we want to write each equation in exponential form. So looking at part A, here is our original equation. So to write this in exponential form, we would simply write down 8 equals 2 to the power of 3, and that completes this part of the question. For part B, we'll do something similar. We have the original equation here, and we would write down 1 over 256 over here, and this equals 4 to the power of minus 4, and that completes the question. In example 2, we have two exponential equations, and we want to write each equation in logarithmic form. So looking at part A, this is the original equation where I've highlighted the base 15 in blue and the exponent 3 in red. So this is how we would write it. So we would have log base 15 of 3,375 is equal to this exponent 3. And now we have it in logarithmic form. And we'll do the exact same thing for part B. So here's the original equation. Base 4 is in blue and the exponent half is in red. So we would write this in logarithmic form as log base 4 of 2 equals this exponent here, a half. And that completes the question. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now, for example 3, we want to evaluate this logarithmic expression. So we have log base 16 of 4. What we will firstly do is make this expression equal to y. So we have log base 16 of 4 is equal to y. And then by the definition of logarithm, we know that we would rewrite this in exponential form as 4 equals base 16 to the power of y, like we've done over here. Now we know that 16 is the same as 4 squared. So we replace the 16 here with 4 squared to give us the following on the right hand side. Then applying the power of a power rule, we would just simply multiply the exponents here, 2 multiplied by y, to give us 4 to the power of 2y. And now that the bases are the same, so we have 4 as the base here and 4 as the base here, we can apply the property of equality for exponential functions to say that the exponents 1 equals 2y. So we'll write that down over here. And then we simply divide each side by 2 to give us the following: a half equals y. Okay, and then we know that this expression we were asked to evaluate is equal to a half, and that completes the question. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Now let's look at the parent function of the logarithmic function. So we have f of x equals log base b of x, and we actually have two types. We have the first one, which has the condition that the base b has to be strictly greater than 1. Okay, so let's see what the graph of this looks like. So before we do the graph, we need to plot in 3 key coordinates. Okay, so the first one is 1 over b minus 1. So whatever your value of the base b is, you would substitute into here to give you the first set of coordinates. The next one is 1, 0, which is the x-intercept. And then the next one is b1. And again, you would substitute your value of b here. Once you've plotted your 3 key points here, you would draw a smooth curve going through these points like so. And in fact, this is the hardest part, being able to draw a smooth curve. So with practice, you'll get better at drawing smoother curves. Now, looking at the second type, we have the condition on the base b such that it's strictly greater than 0 and it's strictly less than 1. So it lies between 0 and 1. Now let's see what the graph of this looks like. So again, like before, we're plotting 3 key points. So we have b1, 1, 0, and 1 over b minus 1. Now, if you compare these points to what we have here, we can see that 1, 0 and 1, 0 lies here, so they have the same x-intercept. And if you compare this one, for example, 1 over b minus 1 and 1 over b minus 1 over here, and we also have b1 over here and b1 over here. Now, the reason the positions are different is because the values of b will clearly affect the coordinates. Okay? Now, once we have our 3 points, we can just plot them in to give us a smooth curve like so. So now that we have these two graphs, we can analyze them to find these properties of the parent function. So for the type of graph this is, we know it's continuous and it's 1 to 1. So it's continuous because there are no points of discontinuity. And if you apply the horizontal line test, we can see it's 1 to 1. Now the domain is the x values. So if you look at the x values from these graphs, you can see it's all of the positive real numbers. And for the range, this is the y values. So if we look at these two graphs, we can see that the range is all the real numbers. And you can see the asymptote here is the f of x axis. And the intercept for both of them is the x-intercept 1, 0. So we can write that there. So please be sure to make a note of these. Now for example 4, we want to graph the function f of x equals log base 5 of x. Okay, for step 1, we'll identify the base first, and we can see here that the base is 5. So we'll write that down here, b equals 5. For step 2, we want to determine the points on the graph. Now if you recall from the previous slide, the points are the following. And we simply substitute b equals 5 over here and b equals 5 over here to give us the following set of coordinates. So now that we have the points, for step 3, we plot the points and sketch the graph. So we have the coordinate axes here. We'll plot in these points like so. Okay, and then we want to draw a smooth curve which goes through these points. And again, with practice, you'll get better at drawing smoother curves that go through all the points. And this completes the question. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now let's look at the transformation of logarithmic functions. So what we have here is the parent function of the logarithmic graphs. And just like other functions you've studied, the same techniques used to transform those graphs can be applied to logarithmic functions. So if this is the parent function, what we have here are values of a, h, and k, which would transform this parent function. So if you look at the value of h would cause a horizontal translation. So the graph would move h units right if h is positive, and h units left if h is negative. Now remember, this is an absolute value of h. So if h equals -7, the absolute value of -7 would be 7. So the graph would be moving 7 units left. Okay, and if you look at the value of k would cause a vertical translation. So the graph would move k units up if k is positive, and k units down if k is negative. And again, this is the absolute value of k. So if k equals -3, the absolute value of -3 would be 3. So the graph would move 3 units down. Now, if you look at the value of a affects the orientation and shape of the graph. So if a is negative, the graph is reflected in the x-axis. If the absolute value of a is greater than 1, the graph is stretched vertically. And if the absolute value of a lies between 0 and 1, then the graph is compressed vertically. So in example 5, we're asked to graph this function here. Now we can see that the base is a quarter. So this tells us that the parent function is f of x equals log base quarter of x. And we'll draw this parent function on the graph like so. Now we should recall that the values of a, h, and k, when we compare them to what we have here, we can see that a equals a positive half and h is a positive 3. So what does this mean in terms of a transformation? Well, since the absolute value of a is equal to a half, okay, so this lies between 0 and 1, this tells us that the graph is compressed vertically. And since h is a positive 3, the graph is translated 3 units to the right. And since k equals 0, there is no vertical shift. Now we want to follow this order of transformations to be able to complete the final graph. So the first thing we'll do is compress the graph vertically, and this is what it would look like. Okay, so now that we've compressed the graph, what we want to do next is to translate the graph 3 units to the right. So if we shift this 3 units to the right, this is what it would look like. Okay, and we know there's no vertical shift, and this is our completed final graph. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.